Well, good day. It's a delight to be here. Good morning to you. It's a pleasure to meet the future of Colombia, the young people at the universities. Your days here will go fast. They'll be intense. It'll be important for yourselves, for your family, for your country. So I'm going to give an overview of some of my experiences in science. And I'll be showing a lot of pictures of people because I think it's the people we meet in our careers that make things happen. I'll share a little bit of scientific data, but it'll be more a matter of sort of what I call my Facebook of science. So let me start by, yes, can we have the lights down a little bit? I realize warm room, dim lights. I will keep you awake. Trust me. Thank you. So I'll start with a little story. My wife loves this story. It was first told by the Nobel laureate Michael Brown at the University of Texas when he won his prize in Stockholm. It's about a Nobel laureate on vacation with his wife. And the laureate is driving the car, and this is in Joshua Tree or Death Valley National Park. And they're running low on petrol. They leave the park to go to a gas station to fill up the tank. And the wife is sitting in the front seat of the car, very serious. The husband, very serious laureate, pumping gas, self-service. And the wife looks through the windshield and she sees an old hippie leaving the convenience store by the gas station. An old man, older than me, long hair, homemade earrings, very poor clothing. She recognizes this old hippie. She gets out of the car and runs across the parking lot and throws her arms around the hippie, kissing him and hugging him. He recognizes her. He's kissing her. He's hugging her. And the laureate is pumping gas very seriously. The tank is full. Darling, it's time to go. Back in the car. He's irritated. He turns to his wife. What was that all about? And she's very somber. She has a tear in her eye. She says, dear, I never explained, I never told you, but before I met you, I was in love with that man. We were going to be married. The laureate bristles. He's really irritated. He snaps. It's a good thing you didn't. After all, you'd be stuck here in the desert, and as you know, I won the Nobel Prize. And she turns to him with anger and says, you don't understand, if I'd married him, he would have won the Nobel Prize. So think about it. In addition to your studies, young men, young women, relationships, you don't know. The next one to win the Nobel Prize might be here. My wife loves that story. People asked her, Mary, what would have happened if you'd married the hippie? And she says, I did. So let's go through the slides. If there are any questions along the talk or at the end, please ask me, particularly if the students have a question. I'd love to share things. So science is, of course, about important physical and natural processes being explained with the well-being of humanity or the planet. But it also has a second benefit, because scientists cross borders. 2 days ago I was in the United States. Now I'm here in Cali, Colombia. We have opportunities that other people, business, lawyers, politicians don't have. We have friendships around the world. But in the United States, there's a lot of concern that the world view of the U.S. is largely negative. This was a political poll by the Zogby firm 10 years ago, when citizens in 5 moderate Arab countries were polled, their impression of the United States. And in general, very few were favorable. The majority had unfavorable. 94% unfavorable in Saudi Arabia. When the same individuals are asked of their impression of the United States, science and technology, and this is global science, drug development, agricultural science, engineering, the response is very favorable, a complete change. These people love science and technology and what the United States does to the world. It's a door that has opened because of what we as scientists, and certainly public health practitioners and medical doctors, are scientists also. So think about it. This is an opportunity in your career to cross boundaries and increase the positive impression of your country abroad, and to make friends who will be your friends forever. So I am now 66 years old. I have arthritis. I have Parkinson's disease. All these. My hair is falling out. My knees ache. I wasn't always like this. I was a young person when I started in science. That was me. I hope you're not afraid. The aging process will happen. But some good things happen along the line. You'll meet a lot of people. So as a 21-year-old, I came to Johns Hopkins to do science. And I was interested in global health, diseases of the poorest of the poor, problems like cholera, malaria, yellow fever. And I had a great opportunity to work in a laboratory at Johns Hopkins with this man, Pedro Cuatro Casas. Born in Madrid, he grew up in Colombia. At the end of the Spanish Civil War, his father, José Cuatro Casas, an internationally famous botanist, refused to work in Spain, came to Colombia. He was on the faculty at the National University in Bogota, the agricultural faculty in Palmira, and about the time Pedro had finished high school, they came to the United States. So he was my boss, and he had an exciting group of people he attracted from around the world. He was the first to use affinity chromatography in biological systems. And the people were exciting. Gianfredo Pucca, an Italian film actor, had an interest in the molecular basis of femininity. And together, these two solved it, isolated the estrogen receptor for the first time. It was exciting. Now, the rest of the lab was not quite as photogenic. But in this group of, it looks like a motorcycle gang, I realize. There's a Spanish anarchist, a Taiwanese biochemist, a French psychiatrist, a Swiss Indian biochemist, a Spanish or a Polish snake collector, a big wave surfer from Hawaii, an eclectic group. Notice no women in the lab then. This was 1972. There were women in science, but far fewer than today. And my job in the lab was interesting. I was working on diarrheal disease related to cholera. Now, one summer we were joined by these two young men in the laboratory, laughing men with beards. Doesn't look so exceptional. But let me tell you something about these two young men. Naji Sahyun, a graduate of American University, Beirut, Palestinian, grew up hating Israel. He had hatred in his heart, suspicion that American Jews were all Zionists. Marvin Ira Siegel, son of an Orthodox rabbi from Brooklyn, New York. His family was Zionist. They thought all Palestinians were unreliable and untrustworthy. But working in the lab together, they became the best of friends to the ends of their lives. This is happening. This is happening here in Cali, Colombia, to faculty. The friendships will be permanent. So I worked on the biology of diarrheal diseases, which has an issue of how water from the plasma and the interstitial fluids can be released as diarrheal fluids. And we solved it in terms of isolation of the toxin, but we didn't understand how water causes such problems when it's at disequilibrium. So later on now, fast forward 15 years, I'm in the faculty at Johns Hopkins. We're working on a problem in red cells, and we discover a protein by total serendip that turns out to be the first molecular water channel, explaining how osmosis occurs. We tested this new protein by expressing it in the eggs of frogs, Xenopus laevis oocytes. And so here's a control oocyte, here's a test oocyte. In isotonic saline, there's no difference. They're about 1 millimeter in diameter. But when transferred rapidly to distilled water, osmosis should cause the channel expressing egg. If it's permeable to water, it should explode, and that's exactly what happened. Presto, exploded the oocyte, and it produced much jubilation in the lab. If you have any discovery in science and you don't feel overwhelmed with joy, you're in the wrong business. That is our pay, the discoveries in science. And we had no idea, we were such a small lab, that there was some significance, some major significance to this. We knew it would be interesting. We had no idea how far it would go. So I'm going to now share with you some photographs of my colleagues who helped us take this simple discovery and make it an important biological event in textbooks all around the world. And I'll concentrate on the people, not the scientific details. This is Søren Nielsen. He was 29 years old when we started working together. He was a microscopist from Denmark who pinpointed the localization in the proximal nephron of the kidney, where renal concentration occurs. Defects in this found, for example, in this lady, a French school teacher in retirement who came to the U.S. cannot express this protein, and she cannot concentrate her urine fully. This is urine concentration in the aquaporin-1 null individuals. Normally, when we sleep through the night, we concentrate our urine from physiological plasma, about 280 milliosmoles, up to 1,000. This is all normal people. She can concentrate partially, enough to get through the night. But if she were stressed, if she were in a long hike in a hot climate without access to water, she would drop of dehydration long before anybody else. And we solved the structure of this protein aquaporin-1 in collaboration with these two gentlemen, Yoshinori Fujiyoshi from Kyoto, Andreas Engel from the Biocentrum in Basel. So we really understand how it works. Basically, it's a pore that allows water to cross the membrane, 3 angstroms in diameter. So here's viewing the pore from the top of the cell, and here's viewing in cross-section. Water moves through the membrane or out, depending on the osmotic gradient. Now, the aquaporins, as these are termed, are pretty well understood in biology. I imagine many of you students in your biology classes learned about water channel proteins, the aquaporins. And there are 13 human homologs, and there are more than 500 non-mammalian homologs in the genetics database. All life forms have water channels related to this protein. So I'll tell you briefly about each one, or some of them, but concentrating again on who did it. Masato Yasui, postdoc from Tokyo, Japan, worked on the aquaporins in the lens of eye. Genetic defects lead to cataracts in small children. Aquaporin 4 in brain, our colleagues in Norway, Ole Petter Ottersen and his team, localized it at the perivascular membrane, the blood-brain barrier. This is an important part of the brain. Our crania, our skulls are fixed to protect the brain from injury, but if you sustain a severe injury, there can still be intracranial swelling. Since there's no room to expand, swelling of tissue causes compression and brain damage. His junior colleague, Mahmoud Amiri Mohadam, solved this in a very important way. Let me point out that Mahmoud Amiri Mohadam is not a typical Norwegian name. Mahmoud started his scientific career in a refugee camp in Pakistan. His family fled Iran at the time of the Islamic Revolution, the persecution of university people. He was adopted by the Norwegian Social Services. What he discovered is that normal organisms, normal mice, after a defining brain injury, sustain a significant amount of brain edema and infarct. But if they could develop mutant mice, the same injury caused much less brain damage. Now, we can't make mutant people, but what this shows is that if we could inhibit the protein, we would have a new approach to the prevention of brain damage after head injury. A very important object. Surabhi Raina from New Delhi, India, a postdoc in the lab, cloned the aquaporin 5, the gland that allows water to be released from salivary glands, lacrimal glands, sweat glands, really important to survival. And as I said, all living organisms have these. Plants have aquaporins. This is a slide borrowed from Ralph Kaldenhoff from the University of Würzburg. The normal Arabidopsis, nice foliage, a thin arborization of rootlets, a very efficient water uptake. The engineered plant has a decrease in expression of the plant rootlet aquaporin. So this plant has only 20% as much water uptake from its rootlet, but it maintains stem turgor and foliage because it sends out more rootlets. When the rains stop, the animals will move to new water holes in the savannas of Africa. The plants that remain behind compete for water. This is how they do it. So there's a subset of the aquaporins that are permeated by water plus glycerol, the 3-carbon polyol. We call these aquaglyceroporins. And they're expressed in a number of tissues, including the basal levels of skin. The skin creams that we purchase have glycerol, and it hydrates our skin by moving into the basal level. Now, this caused a lot of interest in the beauty industry. I was visited a few years back by the executive officers of Christian Dior. Now, I don't normally have visitors from the executive offices of Christian Dior. I was suspicious that they had a commercial reason for the visit, and it was true. They have a product which now is on the market. They would like you to buy. It's very expensive, 50 euros for a 50-gram jar. Their chemists have found some natural compounds that induce the expression of aquaglycerin-3 in sun-exposed skin. I should point out, I have no financial ties to Christian Dior. My wife thought that was a big mistake. But financial ties to the beauty industry brings restrictions. Anyway, if you buy this and use it, they would like you to think you'd look like this. I'm not personally convinced, but that's the advertising. Now, this is the back cover of the Marie Claire Beauty magazine. In French, you'll see bold statements, profound hydration, spectacular results. And what's this? The Nobel Prize in Chemistry. I showed this to my mother, 80 years old, a farm girl, never went to university. She sees this, she says, Peter, I think you're finally doing something useful. Our mothers know us better than we know ourselves. I think she was kidding, partially, but I think there's some useful things that will come from this work. And the same protein, the aquaglycerin-3, is present in red cells, allowing glycerol transport into red cells, which turns out to be extremely important in malaria. Malaria, the new adventure in my life. Malaria, a major killer throughout the world, and here in Colombia also. So the parasite invades a red cell. It will grow and divide rapidly, but it cannot synthesize glycerol. It must take glycerol from the plasma through the plasma membrane, the vacuolar membrane, the parasite's membrane, through the different aquaglycerophores. In a series of knockout studies, we saw that we could reduce the virulence of the organism. Probably not enough to be a drug target. Now, malaria is a cruel disease because a parasite infects a red cell. Here's a single parasite in a red cell. It can grow and divide 2, 4, 8, 16, 32 daughter cells in just a couple of days. And when this cell breaks, it'll release 32 parasites. So do the numbers, 32 times 32. In 2 cycles, that's 1,000 parasites. In 4 cycles, that's 1,000,000 parasites. 6 cycles, 1 billion. A rapid amplification, causing horrific fevers, brain damage, kidney damage. And some will survive, some will not survive. Aquaglycerophores are also important in arsenate uptake. This is a problem in nations such as Bangladesh, which have arsenic-contaminated drinking water. So these are important in public health. So an amazing thing happened in October of 2003. At 5:30 in the morning, the phone rang. A very pleasant voice on the other end, a Swedish accent. This is an important telephone call from Stockholm for Professor Peter Agre. Are you Professor Agre? And I said, I sure am. And the Nobel Chemistry Committee told me I would share the Nobel Prize in Chemistry with Roderick McKinnon, a physician scientist from Rockefeller, New York, for the discoveries of channels. Well, I was pretty excited about this. I was not a very good science student in high school. So I'm listening to the Nobel Chemistry Committee telling me about the Nobel Prize in Chemistry, thinking, do I tell them that I got a D in high school chemistry? I'm imagining my high school teacher aspirating his cornflakes when he hears the news. His worst student. You never know. Then they told me we would have 10 minutes have a press conference in Stockholm and I should get ready for the day. So I sprinted to the shower. And my wife, Mary, organized, calm, took that moment to call my mother back in Minnesota. An old lady living alone. My father, the chemistry professor, had died 8 years before. And she told Ellen, my mother, what was happening. And my mother thought for a moment. She said, Mary, tell Peter that's very nice, but don't let this go to his head. She was still on that do something useful business. And she was right. But things get carried away. On the way home from work, the local liquor store, whoops. The local liquor store is not advertising the price of Heineken. It's Dr. Agre. You have no control about this. I'd like to point out that the implication that I'm their best customer is a huge exaggeration. But here we are on the stage. I had a big mustache back then. I'm kind of growing it back now. Any resemblance I had to Alfred Nobel was sure coincidence. But here's my wife, my children, and the Nobel Prize. And it was a wonderful event, but let's be honest. Every year these announcements in October are splendid. The whole world awakens the notion that science is being rewarded for some discovery that will change the lives of people on the planet. And there are so many great scientists with so many great projects. It's a lot of luck to be called. But I think in terms of PR, public relations, the Nobel Prize is great for science and for what all of us are doing, whether it's in public health, engineering, architecture, medicine. It's a reward of visibility that brings the public's interest. So our new adventure, as I said, is malaria. We're 100% committed to malaria now, which is a great problem in the developing world, mostly in sub-Saharan Africa, in some parts of Asia, again in the Amazon region, and some of the highlands here in Colombia. But the work of many labs around the world, work here in Colombia by Socrates Herrera and his colleagues at the Caucaseco Institute, are bringing it under control. But there's much more to be done. Some young people in this audience, I think, will join the malaria effort. I hope so, because it's going to be a long, difficult process to eliminate malaria. And it leads to lots of deaths in sub-Saharan Africa. And the victims are, of course, the children, the innocent kids. In previous years, youngsters like this, these are playing outside of our field station in southern Zambia, would all get malaria. But now we can protect them. We can treat them. It's understood, and the prevalence has been diminished greatly. But not everybody is so lucky. This young boy brought to the hospital, or Dr. Philip Tuma, our colleague from Johns Hopkins, who works in sub-Saharan Africa, saved his life. The boy was brought in the hospital in coma. His life was saved, but notice he has a disconjugate gaze. He's blind. The malaria has killed the cerebral cortex in the visual area. They'll never see again. So there's a lot of suffering. So our institute is at work in sub-Saharan Africa as part of the International Centers of Excellence, one of 10 such centers in the world. One of the 10 is located right here in Colombia at Caucaseco, Dr. Herrera's colleagues. And here's our team in southern Zambia, African workers, working very diligently and making great progress. So this is a single data slide I'll show. This shows the prevalence of malaria in the region around the hospital in southern Zambia where we're working. For decades previous to the turn of the century, hundreds and hundreds of cases, usually over 1,000 cases each year with dozens of deaths. But then the introduction of the modern treatment, the artemisinin in combination, saved, and with aggressive tracking of the disease, reduced the prevalence. Because of a stock outage, medicines were not available, the parasites came back. And when reintroduced with insecticide-treated bed nets, now we're down at much lower levels. Still some children coming to the hospital and a few deaths each year, but much better, 97% reduction. The control can happen, but we need new efforts, new medicines, new vaccines to take it from here to zero. Because if we stop now, it comes right back. So the people that develop malaria often are not in urban settings or in rural villages. It's hard to get to. In rural Africa, there are no road maps to these hinterlands. This photo was taken on a visit to a malaria village at the beginning of the rainy season. The grass is just starting to grow, but by the end of the rainy season, when malaria is maxed, the grass is 2 meters high. It's hard to get there. But in these sites, you have hard-working subsistence farmers, perhaps the last innocent people in the world, working their hearts out to support the family. But then the malaria will strike some of the children down. So by surveillance, things are coming under control. And while they're not gleeful in the photograph, these people are really grateful for what is being done for them. Of course, they have hard lives. They're using agricultural implements which were discarded in Colombia and in the Western world more than 100 years ago. And everybody works. The children help care for the younger children. They bring the maize to the villages to be ground. But the kids know how to have fun. There's great reverence in these poor communities, in these rural villages for children. They view children as the blessing of their lives. The most important part of the family are the young children. And they're adorable. We need to protect them from malaria. It's our moral obligation to do so. This little girl, I love this picture. Upside down is her school book. It says, "School is cool." Now the mosquitoes that transmit malaria also have aquaporins. I won't go into them. We're studying them now. We don't have a clear idea how these discoveries are going to lead to better control, but you never know with research. The mosquitoes don't respect boundaries. So when malaria is cared for in one region, it has to be cared for in the adjacent regions or it comes right back. So our international center is focusing in Southern Africa, in the region which was once called Rhodesia. Now the northern Rhodesia is called Zambia. Southern Rhodesia is called Zimbabwe. And at 3 sites we're studying this problem intensively. The Mancha research site, which I've talked about mostly, is here. We're also at work in the border of Congo, where the malaria burden is enormous. The efforts in northern Zambia have been ineffective because the malaria crosses the border right back from Congo. Also, we're working in eastern Zimbabwe. I have a few pictures just to show. Now, we think in terms of how rough and dangerous it is to work in sub-Saharan Africa, but they have universities. And these universities are perhaps poor. They don't have the facilities of University del Valle or Johns Hopkins. But they're trying hard, and the young people are very committed. And here's our colleague Bill Moss lecturing at the Protestant University of Congo in Kinshasa. So this part of northern Zambia and Congo is very swampy. It's very flat. There are mosquitoes everywhere. The roads are very poor. But there are wonderful people that live there. And these children, very dangerously at risk for malaria, are adorable kids. And shown with them is Thierry Bobanga, our Congolese co-worker in these projects. And here we are with some of the village elders at work on malaria. Now in southern Zambia, on the border of Zimbabwe, the colonial bridge separates 2 halves of what was once one large country. Zambia with good public health measures on one side, Zimbabwe with big problems on the other side. The government of Robert Mugabe liberated Zimbabwe, but power has been retained, 37 years of control. A lot of corruption, decrease in the public health competence, and a return of malaria. Zimbabwe should be the richest country in southern Africa. Here's a tea estate in eastern Zim. But because of malaria, the people still are suffering. But they're wonderful people. They're gorgeous people. I love this picture of this old man in his sundry finest. He reminds me of a man I met in eastern Zimbabwe. He's a waiter at a hotel. The names are interesting sometimes. Pray more is a name. Love more, one of our colleagues. Help more. The waiter had a name tag at the hotel that says, Never. I said, Never? Is that really your name? And he said, well, it's shortened. My real name is Nevermore. How could you have a name Nevermore? He says, well, I'm the youngest of 9 children. And when I was born, my mother said, Nevermore. You know, these are real people with feelings and with humor, but they have malaria. And the health facilities there are diligently fighting this, but they're having a great challenge because every morning in malaria season, the children are brought by their mothers to the clinic with malaria. They come across from Mozambique. So it shows that these international centers may have locations of expertise, but the work must continue elsewhere, farther along. And here's our colleague Sungano. Unfortunately, Sungano could not make it to this trip. He was held up at the airport in Addis Ababa, a visa issue. An Oxford-educated Zimbabwean is now returned to Zim to dedicate his life to fighting malaria. Now, I'm going to talk about crossing borders in another sense. In 2010, I was president of the American Association for the Advancement of Science. We published Science Magazine. And as part of the AAAS, I was involved in some efforts of science diplomacy, using science to cross borders. And we made trips to hostile countries. We were in Syria. We were in Myanmar, Burma, in Iran. I'm just going to talk about our trips to Cuba and to North Korea. So Cuba, things are coming around, finally. I was 11 years old at the time of the Cuban Revolution, and an embargo was placed, basically isolating Cuba from the rest of the world because of the harsh policies. But the fervor for the revolution is still represented in the older people. Probably some of you young people here or faculty have been to Cuba. It's an interesting place, but citizens of the United States can only recently go to Cuba. And of course, what we find is a very pleasant surprise. Economically, they're having hard times, but socially and intellectually, it's a very advanced country. And of course, they're famous for some of the old cars. The old cars are there because they can't get new cars. And they have a tourist industry. I didn't actually smoke this cigar. And they would like you to pay them money to have your picture taken. My wife hates this picture. I can understand why. What an idiot. What an idiot I was. Where there has been investment, the old architecture is lovely. This is the Hotel Nacional de Cuba in Havana. But where there has not been investment, the architecture is crumbling. So this is an opportunity, really. Now, the scientific community in Cuba is well established. But after the revolution, the country was bankrupt. There was an exodus of many, probably more than 1/3 of Cuban doctors to Florida. And a redirection was made, focusing science to prevent disease, develop vaccines, new methods to prevent illness. One of the first efforts after the revolution, Fidel Castro, Che Guevara, made to the Pan American Health Organization to control and eliminate malaria from Cuba. They succeeded. It was a major effort. So here's Fidel Castro, whose son is a scientist. He's a friend of ours. His name is also Fidel Castro. It's Fidel Castro Diaz-Balart. This is Fidel Castro Ruiz. And he arranged for us to meet with his father one evening. This was 3 years ago. Imagine that, an evening with Fidel Castro. This man is extremely brilliant, very engaging and forceful. We had a conversation for 3.5 hours. He did 99% of the talking, like this, of course. And we were listening, learning interesting things about the reasons for the revolution, including the need for universal health care, which is now available. It was a very fascinating evening. And of course, there are many things we disagreed upon, but in science, it's what you agree upon that counts. So by the end of the evening, an aging Cuban ex-dictator and an American grandfather could shake hands because the science is something we agree on. So his son arranged for me to lecture at the University of Havana. I always love to come to the universities to meet the young people. It's a lovely university. And at the end of my lecture, I was astonished, the enthusiasm. Here I am surrounded by their students. They want to do science. They want to join the global community of science. It's an opportunity for us, and it will be an opportunity for them. So I'll close by talking about our visits to North Korea. This is a very serious and stern place to visit. It's probably the last place most people will go. They're so isolated from the world. For 60 years, they've lived in isolation, dependent upon China. But they have a scientific community in North Korea, too. And here's our group meeting with a leader of the State Academy of Science outside one of the laboratories in Pyongyang. But Pyongyang is a city. It looks like a city, but there's something missing. The electrical grid shows minimal electricity. It's isolated. It's underpopulated. It's not representative of the real North Korea. This North Korea is run by the Kim family as a gang. Kim Il-sung on the right, his son Kim Jong-il on the left. They're both dead now, and the grandson Kim Jong-un is running the country with great cruelty. People are intimidated, but in spite of that, the science goes on. People are implored to work hard for the country. And on display at the great reading room of the nation in Pyongyang, what should be there but our magazine, Science Magazine. We met the scientists doing biotechnology, crop research, because North Korea cannot feed itself. They're dependent on aid. They will never admit it, but they're dependent on aid. They have a need for science, and I think this science is the door, an opening. Now, there's an opportunity, even in North Korea, through a university, to have some engagement. Pyongyang University of Science and Technology is an English language university funded by an American businessman born in Korea, James Kim, who wanted to do something to bring the countries closer together. The students now only has some women students. When I first visited in 2009 and again in 2011, it was all men. I'll return in a few months, in October. And they marched to class, very serious, in suits, singing patriotic songs, basically death to the United States. I don't think anyone would describe Pyongyang University of Science and Technology as a party school, unless you're talking about the Communist Party. And they sit in great attention, listening, politely listening. They would never laugh at a joke. I told the same joke about the Nobel Prize. No one laughed. And then I explained, that was a joke, that's funny. Then they all laughed. It's interesting. They're intimidated because they're being observed. Here are two students talking to the North Korean press, and over their shoulder, they're being observed, always observed. Intelligence agents. Fear to break from conformity. But in spite of that, there's some human beings there doing science. And this is my favorite picture of my friend, Dr. Rong-Gi Hong, the director of the International Bureau of the State Academy of Science of the Democratic People's Republic of Korea. And we've worked together now, we've become good friends. At the end of our first visit, after 1 week working together in Pyongyang, he shared with me a story. We were at breakfast the last day. Children in North Korea are browbeaten into thinking Western people are aggressive and dangerous. When he told his 6-year-old grandson he'd spent a week in a hotel in Pyongyang with Americans, the little boy became very frightened. He said, "Grandfather, bring the rifle." Dr. Hong thought this was amusing. I really didn't know how to react, but I had an unopened box of granola bars in my suitcase, which I gave him. I said, "Give these to your grandson." 2 years later, we met for the second time at the Carter Center in Atlanta, Georgia. Our State Department allowed us to bring the State Academy leadership across to the U.S. The meeting started with a serious sit-down, a long table. I was the head of the American side in the center. Across from me sat Dr. Hong, who read a prepared statement, very critical, very aggressive. It was rehearsed. He was forced to read this. And my chance then was to respond. And I didn't know what to say, so I said the first thing that came to mind. I said, "Dr. Hong, how's your grandson?" Suddenly, the severe face turned into a little smile. He said, "Why, he's fine." I said, "Did he tell you to bring the rifle to Atlanta?" Then he cracked up. He said, No, my grandson said, but please bring back some granola bars, some candy." And maybe this is really what represents science diplomacy, the friendships between scientists, occasions that bring our countries closer together. So in closing, I'd like to share some wisdom from the East. Mandarin, the character for crisis, Wei Ji. Korean is very similar, it's Wei Ji. And this is two characters. Wei, a time of danger. Ji, a time of opportunity. And this is, I think, what science is all about. The dangers, the pestilence, the droughts, the global warming, malaria, Ebola, and the opportunity because of research in laboratories and public health facilities around the world to take care of this. 1 second. My last slide. So now, at the end of my career, I look back and I think in terms of the science made many wonderful opportunities, but the friendships were the very special part of this, and the friendships will last forever. So with that, let me thank you for the opportunity to visit you here at University del Valle, and I'd be pleased to answer your questions. Thanks so much. We can have the lights up, and please ask the question. Viral infections. Am I hearing right? Did you say viral diseases? Yes. In fact, vaccines are most effective for viral diseases because of the simplicity of the viral genome. The polio vaccine, which was developed when I was a small child, is highly effective. Probably more than 95% efficacy, long-term protection. Vaccines against parasites like malaria are much more difficult because the parasite is a complex genome with 5,000 genes. So I think the greatest success has been against viral diseases, but not all viral diseases. We get flu vaccines every year, but then the phenotype of the flu alters and it's less effective. So vaccine development is enormously important. And it's a major research effort by Dr. Herrera and his team at Calcaseco to develop a vaccine for malaria, because we still don't have a good vaccine. I think that's fair. Are there other questions? Did I answer your question? great. We look forward to your contributions in science. Thank you. I hope you do. It would be so important. Do we have time for some other questions? Are there one or two more? Young people.
Tenemos el micrófono aquí. Vamos a hacerlo con el micrófono para que sea más claro.
And if you wish to have it translated, we can have that happen too.
Oh no, it's all right. I wanted to ask something about like science in the U.S. because you spoke a lot about the science part of the conference you've visited, but I've read lately that there has been like some sort of anti-science movement in the U.S., anti-vaccine and stuff like that. So I wanted to ask your opinion or your position in that respect.
Very important point you raised. The public understanding of science. In the United States, we're a very rich and privileged country, but we have a lot of difficulties with our communication. And there are even political leaders who are unfavorable towards science. They choose a political position and present that as a controversy, even though 99% of science is clear. Global warming, for example, is not a myth, it's a fact. So the communication of science through journalists is very important. But the communication of your knowledge, students and faculty, staff members, to share when you hear people discussing science what you know to be the truth. Sometimes you have to be very tactful. And people are aggressive, they won't take correction. But I think we have to wait for our opportunities to communicate with the people. And as you get further established in your careers and you have opportunities, as I have this morning, to speak to the press, it's important to use those opportunities not to oversell science. We can't make cancer vaccines that are going to be perfectly effective quickly, but the opportunities are there. So I think the U.S. has significant problems with communication, as does every country. Thank you. Yes, please.
Yes, my name is Lida Osorio. I'm a physician epidemiologist. I used to work in malaria.
Great.
Now I work in dengue.
Okay, another important problem.
Yes, it was in answer to that local problem that I moved to work in dengue. But my main concern now, being a teacher here at the Universidad del Valle, is actually how to provide an environment where those future Colombian Nobel Prizes are going to develop. And I would like to hear your advice to being a better teacher for those future researchers.
Well, you're very kind to ask that. May I ask, did you do all of your training here in Cali, or did you do some other traveling? Sure. So you have to realize that oftentimes science gets complicated, and sometimes in your home university you have all of what you need, but oftentimes doing graduate study at another university or postdoctoral study at another country, you can expand your horizons. I think there will be Nobel Prizes in the sciences here in Colombia. I mean, in literature, of course, we have Gabriel Garcia Marquez, a hero to many of us. But in science, it's still out there. But I think using the opportunities, taking the study seriously, and looking for opportunities in the laboratory, this is important. And if it means doing a postdoctoral fellowship in Australia or Japan or Europe or the United States, that's okay. Having retained the loyalty to your home country, though, even if you should be working abroad, returning, training the young people, we're a community. Nobody has a monopoly. In the United States, half of our Nobel Prizes go to people born in other countries who come to the U.S. for science. So we're part of a community, and I think your teaching efforts will be very well rewarded by the success of your young people. I'm asked, what are the real rewards of science? I can think of only three things. Original discovery, the respect of your peers, and training the future scientists. That's it. If you get a Nobel Prize, that's great, but that's not essential. Thank you. Another question or two? Yes, please.
Hello, sir. So I've seen a film called Sicko. It's from Michael Moore, and in this film he depicts like the reality of American National Health Service. And he makes a comparison between, for instance, going to the U.S. and going to Cuba. Like in Cuba, well, they lack many resources and everything, but still what he depicted in the film is that they get more access to all these resources. So my question is, when you went to Cuba, so we've seen your photos and everything, could you see that contrast? Could you see that image of universal health service over there?
Sure. Well, first off, I've seen Michael Moore's movies. I've seen Sicko. And I have to say, first off, Michael Moore is an excellent film director, but he's not a scientist. And so Michael Moore is selling tickets to the movie. I don't think the health system in the United States is inferior to Cuba. The distribution could be much better. And for many of us, for me, I get great health care. But there are others from poorer areas that they must wait in long lines. There are a lot of delays. There's room for improvement. Cuba has universal health care. It's not as comfortable and luxurious as maybe many of the clinics in the United States. But what is the median lifespan in Cuba? It's about 80 years. It's slightly longer than the United States. So in terms of who lives longer, they win, or it's a tie. So I don't think it's important as much how much you spend as how it's organized. And if you can prevent people from becoming sick, and that is the object of you as public health students, to prevent disease. You can not only improve human well-being, you can save money. So I think the concept that Michael Moore presented is correct. And I think good health care is provided in Cuba. But the embargo has made it very difficult. Salaries are extremely low. You'll have a neurosurgeon hitchhiking to moonlight in a restaurant as a waiter to support his family. That is not a good system. Thank you for your question. How are we doing?
¿Tenemos otra pregunta? Sí.
Thank you for your visit, Professor.
Oh, it's my pleasure.
Quick question, main question. Did you ever do anything in your career thinking that you were going to get the Nobel Prize?
When I was a child, my dad, who was a chemistry professor, he talked about the Nobel Prize. So I knew about it as a youngster. And the prestige was presented. And he had a friend named Linus Pauling who had 2 Nobel Prizes, one for chemistry and one for peace. So I was aware of it. But, you know, you're a kid. You're interested in baseball, girls, camping, lots of things. It was not my expectation. I'm very pleased that it occurred, but I had a happy life before that, and I'm still having a happy life. And so the journalist asked me, how has the Nobel Prize changed your life? I point out that our family dog does not love me any more than before. And if I'm lucky, my family still loves me. Thank you. Well, thank you all. I appreciate you turning out. You're so kind.